two figures to be similar? Same shape, right? Congruent angles. If they're similar, do they have congruent sides? No. But the sides should be proportional, right? They should be in the same proportion. So all corresponding sides. So when we talk about similarity, we have same shape, not the same size. Okay. However, all angles are congruent, and all corresponding sides are in the same ratio. Okay. So if I were to set up a proportion between two pairs of corresponding sides and check cross multiplying, it should come out correct, right? Yes? And if you think back, okay, so we have two figures. Basically, you know for sure without being told that cubes are similar because they're cubes. All the dimensions are the same, right? And spheres are similar because they're circles. So there's no, there's only one dimension in a sphere, and that's the radius that you can talk about. So in a cube, say we have, we'll make this not necessarily a cube. We'll call this 3, 3, and 2. So this would be 6, 6, and 4. So in a rectangular prism, if we wanted to talk about a similarity ratio, we use one pair of corresponding sides. Okay, in order to set up the ratio, if I used 3 to 6, that would be a similarity ratio, knowing that these two are similar. But if I were checking, I'd have to check all 3 sets. Now you don't have to write 3 to 6 twice, but you should check 2 to 4. And you can either cross multiply on those, or you can turn them into a decimal if you're just simply checking for similarity. This is half, and so is that. So if you check for your decimal, 0.5, they should turn into the same decimal when you do top divided by bottom. But if we wanted the actual similarity ratio, we want the simplified ratio, not a decimal. So the simplified ratio would be 1 to 2, or you could write it 1 to 2 that way. But remember, for ratio, you've got to have two numbers, okay? Can't just be one number. You can't say, oh, the similarity ratio is 0.5. That's not a ratio, okay? So to set up similarity, we need the two numbers. They do need to be simplified. Now, when we talk about how that applies to what we're doing now, remember we said in general, if similarity is A over B, that is also the perimeter ratio, right? Because they're both just lengths. And we already talked in the area chapter where the area ratio then should be A squared over B squared. So applying that to solids for volume, how do you think we adjust that for volume? Yeah, it's going to be A cubed over B cubed. And if you remember from that previous unit, if we had the similarity ratio and we wanted the area ratio, we simply squared the A over B. If we wanted area and to go back to similarity and or perimeter, we took the square roots, right? So you're going to do something similar with volume. If you have the similarity or perimeter ratio and you want the volume, you can cube those, or going back to similarity, you can cube root. So if we are going this way, we figure out the other one with exponents. But if we are going back that way, we use roots. Okay, so to get from similarity to area, we use exponents, or to volume, we use exponents. But if we're going backwards, then we use a cube root or a square root, depending on which one you're starting with. Okay. All right. So if we have a similarity ratio of 3 to 5, then you should be able to give the area ratio and the volume ratio. Okay, but everything you do to get one of these, you have to do to the similarity ratio. So area ratio would be 3 squared over 5 squared, which would be 9 over 25. Volume ratio would be 3 cubed over 5 cubed, which would be 27 over 125. Okay. And these look big enough sometimes that it might seem like they should simplify, but if this is simplified, then that is as well. If you're squaring or cubing a simplified fraction, then you're not going to have to simplify it at the end. Okay. Now, that would be one of the easier things to do. Now, if I gave you a volume ratio of, let's see, 729 over 1331, and I want to go to a similarity ratio, okay, in my little lineup, that would be going back to a simpler version, so you're going to use a root. And since we're starting with volume, okay, to get to similarity, we're going to use a cube root. Now you might want to make sure that this fraction is totally simplified. Okay, if you go to take cube roots and you're not getting whole numbers, then chances are they gave you one that could be simplified. You want to do that first. So take your calculators a second. I want to make sure you're practicing with those cube root keys. So you're going to take the cube root of the top and the bottom separately. Don't try and do the whole fraction because we're not looking for a decimal answer. Okay, so if I do the cube root of 729, then I get 9. And the cube root of 1331 is 11. So that is my similarity ratio. Okay, so when you're trying to get from one to the other, you're either using exponents or roots. Okay, but the thing that you need to remember, and I'm going to flip it back over for a second. Well, we'll do it here. You cannot go between these two, not instantly. If I'm given a volume ratio and I want an area ratio, I have to go all the way back to similarity and then square it. So if I start here, I'm going to do a cube root and then square it to get there. Okay, so you can't go directly from here to here. You've got to go back kind of to your starting point. If I'm given an area, then I'm going to square root it and cube the result to get the volume. Okay, so it's one more step than what you were doing with area, because if we're given one of these, we have 2 steps just to get the proper ratio. Now, if you recall from the area chapter, if we're looking for another volume or another area and we're given a ratio, once we get the correct ratio, we can use it to set up a proportion. So we're going to do one of those next. All right. So say you have a lateral area, which is just an area of 1019 and 425. Okay, so these are lateral areas of paint cans. The volume of the smaller one is 1157. Find the volume of the larger. All right, so you're going to start out with a ratio, and these are areas, so we start with an area ratio. If you want to go smaller to larger, be consistent that way. Let's do 425 over 1019. Okay, so we're going to have to do square roots, but the first thing you should notice when you take the square root of 425 is it is not a perfect square. Okay, so we might want to simplify that down if possible. Does anything go into that? It's going to simplify it down. Not looking like it. All right. Anything?
Can you just change the number to make it easier just for the exam?
Okay. Yes, we'll do here. All right. Let's change these. We'll do 128 and 250. All right, we'll change them. That's not a great one to start with. Okay, so 128, 250, and the volume of the smaller is 380. So set up an area ratio with 128 and 250. Okay, those are not perfect squares, but they're both divisible by 2, right? So the first thing we're going to do is simplify. We're not changing it from an area ratio yet. If you divide by 2, we get 64 over 125. Sorry, that's still not a great one. Change that to 200. sorry, I want to make this one as easy as possible. So 200, so this will be 100. All right. So these are perfect squares, yes? Yes? Okay. So we simplified. Now you're going to take the square root to get to similarity. So the square root of 64 is 8. The square root of 100 is 10. Yes? Now we are going to volume. So what do I do to get to volume? Cube. Okay, so we went back to similarity. Now we're going to apply the exponents to get the volume. So I'm going to cube my similarity ratio. 8 cubed is 512. 10 cubed is 1,000. Now, since we're going to set up a proportion anyways, I'm not going to bother simplifying this. But if I were just looking for the volume ratio, I'd want to simplify before I cube. That way I don't have to simplify later. Okay, now, here's the volume of my smaller solid. My last step is to set up a proportion using the appropriate ratio, which I have here. This is a volume, so I need a volume ratio. So I'd say 512 over 1,000 equals, that's the smaller. So that would go on the top. V or X or whatever variable you want on the bottom for the larger. And then you're going to cross multiply. So we're multiplying these, dividing out the 512. So the volume would be about 742 if we round it to the nearest whole number, and that's cubic units. We're going to do some of your homework problems instead of separate examples, so make sure you jot these down. So basically, the two parts in 1 through 4, are the two figures similar? You need to check both dimensions. Okay, with a cylinder, it's just you have a diameter and a height, so you need to check both of those. And then give the ratio if they are. So diameter to diameter, if you go left to right, would be 18 to 12. And height to height would be 30 to 20. Okay, these both simplify. 6 goes into 18 3 times and into 12 twice. 3 to 2, and that's 3 to 2. So they are similar, and the ratio would be 3 to 2. Okay, so 1 through 4, that's all you're doing is deciding if they are similar. If you have a triangular, or not triangular, if you have a rectangular prism or anything like that, you need to check all 3 dimensions.